Now let's expand on our address validations and assume that we need to check the state portion of our address against some predefined list of states. How can this be done? Well, first of all, the increased complexity of invariants for one of our properties means that we need to introduce a separate value object for that property. So let's do that. Create a state class. The class is very similar to all other single property value objects, but this time we will also have a list of predefined values in it. I'm listing just 2 states for brevity, but you can assume that we've listed all 50 states here, and a property that contains a list of all states. Now we can add a validation against that list. If the client tries to create a state that is not in the list, we are saying that this state is invalid. And I need to move this class because I accidentally made it internal to the address class. Good. Now we can use this new value object in the address entity. In the create method, I'm instantiating an instance of the state class, removing all state checks. We don't need them anymore since we've moved them to the state class. Notice how I'm creating the state object. This code assumes that the state was already validated and throws an exception if it wasn't. That's because we don't want the address class to report errors related to the state value object. We have the new class for that. Now in the addresses validator, we can specify child rules for each address. One of these rules is going to be the rule we already have, saying that the whole address DTO must conform to the address entity invariants. The second rule is going to be the rule for the state property specifically. Note that because of the way we've implemented the address factory method, we don't want the second rule to be invoked if the state field is invalid. Hence, I'm asking the Fluent validation library to stop the validation process if it finds an error with the state field. Let me fix a compilation error. Okay, let's run the application. If I modify the state to an invalid one, then you can see that it's been reported correctly. Notice that this string contains the full path to the field with error. This is the reason why we are reporting state-related errors separately from the address entity, so that Fluent validation is able to report them using the correct field name. If I change the state to the one not in our list, then it triggers our check against the list of possible states. And if I put DC here, then the student is registered successfully. Very good. Let's expand this use case even further and say that we want to check the list of states not against some hard-coded list, but the list of states that comes from the database, which is another quite common use case. Is it possible to do so? Yes, it is. But first, let's create a new class that will be responsible for querying states from the database, state repository. In it, I'm just adding a method that returns a stub with all the states in our application, because remember, we don't deal with any databases in this course. Now, how can we use this repository? Fluent validation supports ASP.NET dependency injection, and so we can inject the service provider in our validator's constructor. This service provider is the service locator, if you're familiar with the dependency injection terms. It will allow us to locate the state repository. Now, to actually use this provider, we need to pass it all the way down to the addresses validator. And now, in the mustBeValueObject extension method, we can extend the delegate we're passing as the argument. This delegate will request the state repository from the provider, and for that I actually need to add a using statement. I can now use the repository to request all states and then pass those states to the factory method. The state value object will validate the input string against these states, removing the hard-coded states and using the argument instead. Note that we can do another transformation here along with the string trimming. We can transform the state to the uppercase, which is the usual notation for all states in the United States. Also notice how we are not making the state value object refer to the database, but instead we are passing the full list of states as an argument. That's because we want to preserve the purity of our domain model. Domain classes should not refer to the database in any shape and form, neither directly nor indirectly. We'll discuss domain model purity in more detail in the next module. Alright, we also need to modify the address entity. It needs the list of states as well to pass it to the state value object. And since we've modified the signature of the addresses factory method, we need to update the Fluent validator too. Resolve the state repository and get all existing states. And let me also align this method call with the previous one. Perfect. In the student controller, we need the state repository as well in order to create the address entity. So I'm saving that repository to a private field and using it here. Let me quickly update our fake student repository. I'm just passing a collection with one element as the list of all states. This is the old student validator that I used to make the point about reusing data contracts. We can remove it, we will not need it anymore. And finally, we also need the service provider in the edit personal info request validator. As for the edit personal info controller method, I'll just comment this code for now. Alright, let's run the application. Changing the state to an incorrect one, and I actually forgot to register the new repository with ASP.NET. Let's add it in the startup class and try again, sending the same request, and you can see that our validation still works. And if I change the state back to a correct one, then the API successfully registers the student. Very good. And one last thing. We don't actually need to inject the service locator here. We can ask ASP.NET to inject the repository directly, so I'm changing the argument everywhere. Here too. And we can simplify the two delegates and turn them back to one-liners. Doing the same in the other validator. Perfect. Let's discuss what we did so far. In the previous two demos, we validated our address entity. We also discussed the general guideline of when to introduce a value object for a domain concept. If a domain concept only has one simple invariant, such as, for example, the maximum string length, then I recommend just leaving it as a primitive type. If it's something more than that, for example, a check for email validity, or as in the example with the state field, a check against a predefined list of items, then introduce a value object to encapsulate those invariants. This is not a strict guideline though, and depends on your project specifics. If your domain model is simple or the project is short-lived, then you might want to introduce value objects only for the most complex types. On the other hand, in very complex projects, you might want to introduce value objects even for the simplest domain concepts. Note the seeming contradiction of this guideline with what we discussed earlier in this course. The second building block of the good validation technique tells us that all validation rules should reside in the domain layer. At the same time, I'm advocating for moving some of them to the Fluent validators and controllers. Why is that? Well, think of it this way. Having all, even the simplest validation rules in the domain layer is the ideal, but that ideal requires investment that might not be practical in your particular situation. And so be pragmatic about this decision of where to put those validation rules, but make sure that this decision is a conscious choice. If you decide to put validation rules to a Fluent validation class, don't rationalize this decision by saying that simple validations are a special kind of validations and thus don't deserve to be put in the domain layer. Just acknowledge that it's not practical to create a separate value object for each property with the minimum number of validation rules. Software development is all about strategically chosen concessions and trade-offs. Also keep in mind that this concession often leads to the violation of the third building block of the good validation technique as well. Having validation rules in validator classes means that you will have to either forego any data transformations, such as string trimming or taking the string to an uppercase, or you will have to duplicate these transformations in both the validator and in the controller. Again, this might be acceptable for simple properties, but still keep this in mind. When we validated the address class, we introduced a separate value object for its state property. That's once again because we're following the guideline I just described. It is the only property among all address properties that has more complex invariants than just checking the string length. In our case, we tested the input string against the list of all states. Notice that currently only the state property of the address class has its own value object. The validation rules for the rest of the properties are encapsulated within the address class itself. But as we introduce more validation rules, we may decide to add more and more value objects. For example, we could add a regular expression check for the zip code property to make sure that all its 5 characters are digits. This way, we would get an abstraction hierarchy or an abstraction tree, where all value objects would be responsible for invariants related to individual fields, and the address class would be responsible for any invariants related to the combination of those individual fields. For example, the address class could check that the combination of the zip code and the state is correct. Notice that when validating the state value object, we didn't make that value object reach out to the database. Instead, we're passing all states as an argument. That's because value objects and entities should be isolated from all out-of-process dependencies. Calling those dependencies directly from the value objects would violate domain model purity. Also notice how in the address class we rely on the validity of the state field. This call to the value property throws an exception if that property is invalid. That's because we want all validations to be independent from each other. We want to report state-related errors separately from the address entity. This is done this way so that Fluent Validation is able to report those errors under the correct field, like you can see here. Otherwise, this generic error message will not be enough, and we will have to write custom error messages for each property in the value object. It's always better to return a generic error message while specifying the concrete field where this error took place, rather than return a concrete error message while specifying a generic error field. Finally, notice that all our validations encapsulated in value objects are run multiple times. First when performing the actual validation, and second when the controller instantiates them. This might seem wasteful, but it's usually not a big issue, because most of the time the validation rules in value objects are fast running. And even in the situation like ours with the state field, where we need to query data from the database in order to perform the validation, even then you should be able to cache that data, because it is reference data that doesn't change often.